Welcome back. Today we're going to look at De Morgan's laws and quantifiers. De Morgan's laws relate to negations of and or statements. We can prove that not A and B is the same as not A or not B. To understand this a little better, consider a system with two components in series. The system will work if both components work, but will fail if either component or both should fail. Similarly, consider a system with two parallel components. The system will work if either component is working and will fail if both components fail. It can be proved that not A or B is the same as not A and not B. It's true that and, or, and not are the fundamental tools of logic. However, to make meaningful statements, we can also use quantifiers. In logic, we make statements about things, and quantifiers allow us to be more precise about which sorts of things we're talking about. Consider a statement like, for any real number x, there exists a real number y such that y is greater than x. This statement makes use of quantifiers, for any and there exists, and can be compactly rewritten. One time I showed these sorts of quantifiers to grade 5 students. They said, I thought we were studying math, not Egyptian. Math is weird like that sometimes. It turns out there's a link between quantifiers and the logical forms we've been dealing with. For all is really like a universal and statement. If a statement is true for all things, then it's true for the first and the second, and so on, and so on. Similarly, there exists is a kind of universal or. If there exists an object satisfying some statement, then either the statement holds for the first object, or the second, or so on. The importance of this observation is that De Morgan's laws show how to negate these sorts of statements. Accordingly, the negation of for all is there exists. Likewise, the negation of there exists is for all. More complex statements can be negated in a straightforward manner. Consider the original example. For any real number x, there exists a real number y such that y is greater than x. Its negation is, there exists a real number x such that for any real number y, y is less than or equal to x. Have another look through that and confirm for yourself that these statements are opposite to each other. That is, one and only one of those is true. Some of the terminology in this session has been a bit full on, but hopefully the concepts make sense. Also, early exposure to some symbols helps with gradually understanding them in a more natural way as they come up in examples. Hope you had fun, and I'll see you next time.